This is question 3 of the C3 end of unit test trig, paper 2. We've got 2, 8, 12 marks. Okay, this is very standard for a C3 past paper question on trig. We've got an identity at the beginning, that should be nice and easy. The curves, these two, intersect. Oh, solve simultaneously. And then rearrange to get this. C, we've got a cos angle plus 3 sine, same angle. That's our cos theta minus alpha. We start off with the theta already, sorry, the cos bit. So we want our cos because the first one is cos, and then we just use our pattern. Hence find for theta is in degrees, and theta was in alpha was in degrees here. So first thing we might want to do on our calc is shift menu, angle unit, degrees. And we've got to solve that one. We can't solve that one, but we can solve the Rcos 2x minus alpha thing. Right, going back to the beginning. 3a, use identity. So there's plenty of space down here to answer them, but I'm going to, so we can see the question that we're answering at the same time. Cos 2a is equal to, start off with what we're given. We know that's the same as cos squared a minus sine squared a, but we also know that cos squared of theta plus the sine squared of theta equals 1, and so we're going to get rid of the cos squared bit. So 1 cos squared equals 1 minus sine squared theta. So in here we're going to say that's the same as 1 minus sine squared answer. For the cos bit, take away another sine squared angle, because that's what we had there, and that's equal to 1 minus, so we can have therefore, because this is our final line, cos 2a equals 1 minus sine squared a, and we've got 2 of them, and we're done. Those curves have those equations, so because we can see what we're doing now, if that y equals this, and the same y equals that at the point of intersection, then we've got in part b 3 sine 2x is equal to 4 sine squared x minus 2 cos x cos 2x at point of intersection. Y values are equal. So that's how we've gone from the beginning to that equation. We can write that if we want. I don't think the mark scheme would demand it, but that's completeness. Right, we've got some sine squares in here, and the rest are sines and coses. And we've got sines and coses in our answer. Those are double angles. This is a single. Do we know anything? This is part B, so we're probably going to use some of our answer or lots of our answer from part A. Do we know anything linking sine squared singles with cos doubles? Yes, we do. From there. So these sine squares, 4 of them, are going to turn into cos doubles. So if we start off from there and that one, and we rearrange it, we get 2 sine squares of angle equals 1 plus 1 minus even cos double. So 4 sine squares is equal to 2 minus 2 cos double. So this bit we can rearrange, we can substitute for that bit, i.e. 2 minus 2 cos 2a, in this case x, take away 2 cos 2x. Right, so we've got take away 4 cos 2x altogether. So we can write i.e. 3 sine 2x equals 2 take away 4 cos 2x, and then rearrange it. Therefore 4 cos 2x plus 3 sine 2x equals 2, and we're done. Oh look, that's what we wanted. That's why we wrote therefore. C, express that one in the form of r cos 2x minus alpha. So remembering what we said before when reading the question, r cos would expect cos to be first, and it is. So r is equal to 5, which is the Pythag of 3 and 4, and tan alpha is equal to b over a, 3/4. Therefore 4 cos 2x plus 3 sine 2x is identical to 5 cos let's write at alpha equals tan minus 1 of 3/4, and that's in degrees, so that's 36.87, or 8699 if you want to be 4 decimal places. So 5 cos 2x minus 36.87, and we're done. 3 marks, piece of cake. D, hence find all the solutions to that one. Well, that's exactly the equation that we've just replaced by this one. So in D, because we can't solve that one because of mixed trig equals number, we can solve 5 cos 2x minus alpha, where alpha we've already got determined, equals 2, get rid of the 5, so 2x minus alpha is going to be equal to cos minus 1 of 0.4, or 2/5 if you want, that's equal to. So we're in degrees because we did that already. Did we? Shift menu 2-1, and we want shift cos 0.4, and that's obviously in degrees, 66.42. We want all the answers between 0 and 180. Well, the next answer is going to be 360 minus this, which is 293.58, and therefore 1x would be equal to these answers, add alpha, divided by 2. So if we add alpha onto there, 36.8699, and we divide that by 2, we get 51.65, and we want 1 decimal place, so that's 6, comma, and 293. So I'm going to go back to shift cos 0.4, because that was exact. If we do 360 minus that, we get exactly what we want here, 293.57. Yeah, so we've rounded that. We don't want premature rounding. We've got to add 36.8699 onto that. That's alpha. And then we're going to divide that by 2, and we get 16522, which is 165.2 degrees, or both to 1 dps. And then we can check those by sticking back into the original equation. So if we do 51.6 as answer, and we do 4 cos doubles, cos 2 answers, and we add 3 sine 2 answers, the answer should be ever so close to 2, and oh look, it is. And if we do the same for the other one, 165.2 is answer, and we do 4 cos 2 answers, and we add 3 sine, not tan, 3 sine 2 answers, then we should get ever so close to 2. Oh, we do.